have to, okay, so our goal is to print out the file to the screen. So the first thing I want to change is to make this, I don't have to do read all anymore because we learned about copy. So I'm going to write to os.standardout f, and all that goes away. Okay, so let me comment this out for a second. That writes a single file to standard out. I don't have to read it and then do forward put line because copy does that for me. It takes chunks of the file and sends them to the terminal. So now the trick is I'm only opening one, and I want to open more than one. So I have a slice of strings. Each one of those is a file name, right? So I need to convert that slice of strings. I need to map that slice of strings into a slice of readers. So here's the idea. I'm going to make a slice of io.reader the same length as the args. I'm going to subtract 1 because I don't care about the first one. Remember, we ignore this first one. But otherwise, it's the same length, okay? And then I'm going to walk over each of the args. And now I do need the index here. I'm going to set that one. Well, let me do this real quick. I'm going to open it just like I'm opening this one, right? And so I create the file, and then I'm going to say equal that. So now I have a slice of readers. But I guess I need to change this. Okay? Everybody following what I'm doing here? I'm looping over every argument. So I'm looping to F1, then to F2, then to F3. And I'm opening that file. That's V. V is F1, F2, F3. I open that file. I'm going to defer the close. Remember, these all happen down here. You can defer lots of times. They sort of get put up into a stack, and then at the end, they all get run. Okay? So I'm deferring all the closes, and then I'm putting them inside of this reader's slice. Okay? So now I might have one reader, I might have 20 readers. I have a big slice of them. And now I need to make one reader which reads all of them in order. And that's what the multi-reader does. So I can say reader, equal io dot multi-reader, I think. And then I say readers, remember, dot, dot, dot. Okay. So theoretically, this allows me to cat multiple files. Everybody following? This makes a reader from lots of readers. So let's run it to see. This is my cat. Okay, it built anyway. So when I call it with nothing, it doesn't do anything because I haven't given any files. Okay? And I call it with one file, it prints the file, right? So I call it with, I have a hello text in there. So if I call with file example hello text, you should expect to see the contents of hello text printed at the bottom. Okay? They did. It says line 1, 2, 3. Which if we go look at hello.text, that's what's in there. Okay? So this reader, it goes to the first file that we opened. It reads the whole thing, and then it goes to the next reader. The next reader is the second file, and so on. Until there are no readers left, and then it finishes. Okay? So here's how you can do multiple files. There are other ways too. There's no reason, we don't have to use this. We can do it this way.
Wait, before you do all that, can you scratch that over? Thank
we can, we don't have to store them. We can just write it immediately. So I can just get rid of this, get rid of this. I don't use I, so I can get rid of that. Okay. And this is basically the same thing, it's just the copy happens in the loop. So now I open the file and I write it. And then when that's done, I go to the next file, I open it, and then I write it. And when that's done, I go to the next file, I open it and write it. Okay? Following?
Scratch that over too.
There are many ways to skin a cat. On my cat. Okay. We could keep doing this. I think we're going to have more fun with CSV. So you guys know what CSV is? So CSV, comma separated data. If you've used Excel, you've probably used a CSV file. So this problem is to download a CSV file, state information from statetable.com, and implement a program which takes in the state code and returns a table of information for that state, so the name, region, etc. And we want to use a struct in our program to do it. So we're going to walk through this program together, okay? And then you guys are going to do another one of these that's a little different, but very much the same. So I'm going to call this program, just close all these, new folder, state-information, and then inside of there, I'm going to create a file called main.go, package, main, doesn't do it. Okay, so let's go back to our problem definition. The first thing we need to do is what?
Download CSV.
That's right. So this doesn't even require programming. We have to go download.
Are you checking to make sure we're awake or that our brains are still functioning?
Sure, include territories as well, whatever. Yeah, that sounds great. Wow, there's a lot of options. Here we go, a CSV file that I can open. So now I have a CSV file, state_table. I'm going to move that into this folder. So first, let's go to state information. So you guys following along?
Yeah.
Did you download the state table file?
I'm going to wait and just do that afterwards. You want us to do it with you?
I mean, oops. Okay. So I have a state table CSV. If we open that file, like I said, if you've used Excel, because that's how it normally treats things. So this is
How are you getting there?
getting where?
You download it from the website first.
Statetable.com.
Did you do that in the
You can just click download.
oh, you didn't do it in the,
That's all I did is click that.
oh.
And it downloaded here.
Oh, I thought it was in here.
And then I opened it.
Just go to statetable.com and
And
walk through the process.
it has lots of states in it and other information. Okay, so here's the idea. I have data now. And I want to make a program that shows I can like enter, you know, California, and I can get back that it is in the West region or whatever. Make sense? West Pacific region. Okay? You get the name too. At least that's what the problem stated. Right? Implement a program which takes a state code and returns table information. So this is a table. So that means HTML, right? We can make HTML. Or we could use ASCII. Well, we'll use HTML. And it says we have to use a struct. All right, so when we're thinking about a program, we can like break it down into steps, right? So what's the first step of this program?
Open the file.
Open a file, okay. So we'll just say number one, open a file. And then once we have a file, what are we going to do with it?
We want to make sure it's a slice of bytes because that's often needed. I'm just telling you my thinking. I'm not saying this right.
So
Read it.
we have a CSV file, so we need to parse it as CSV. So parse a CSV file. So I haven't shown you how to do that. What you'll need to know is that, like Scanner, there's a thing that makes us be able to go row by row through a CSV file. Okay? So do stuff for each row. And then what's the last step? Print out a table of the information. Okay. So another way to approach this, so that's like sort of the steps we're going to take. The other way to approach this is the data. I got to think in terms of data. So here I have a CSV file. It very clearly tells me what my data looks like, right? I have the headers, and I have the rows, and there's values inside of them. So that looks like a struct, right? So I can make type, state, struct. And what are the fields of this going to be?
All those headers.
Exactly. Now we don't have to necessarily keep all of them, but we'll just do it for the heck of it.
Yeah, whichever ones you want.
There, now we have a bunch of those. Now we're going to have to give them types. Oh, there's a lot of them. I'm not going to get all of them. We will keep abbreviation. Okay? There. Once again, Go format saves us a lot of trouble. So the ID, that's an integer, wasn't it? That looks like an integer, doesn't it? And the name was a string, and the abbreviation was a string. What else do we want in here? Maybe census region name. So I'll call that census region name. Also a string. So we'll just get those, okay? So now we have a struct. So the struct corresponds with a single row. Right? So, like I said, we don't normally want to break this, put everything in a main function. So I think we probably need a function which takes in a CSV thing and gives us a state. So I'm going to call it parse state. And we don't know what the CSV thing is, so, CSV row. We'll get that type in a second, and it's going to return. What's it going to return?
Parse state.
Yeah.
Well, state.
A state, thank you.
Yeah.
I think I'm going to do this. Turns a state and maybe an error. Because what if I have bad data in there? But the same idea. So if you're going to do that, you probably want to return a pointer to it, because then it can be nil. But either way. So let's go look up CSV parsing.
Sorry, can you explain that pointer thing again? Like why? You said to make it so you can have a nil.
Yeah, so a struct can't be nil. Okay? This struct has 1, 2, 3, 4, 5, 6, 7, 8, plus at least another 8, 8, and 8. So 32 bytes, at least, this struct takes up. Now, if the strings are bigger, they might take up more. So the zero value for a struct, do you guys remember what the zero value for a struct is?
Zero. Or depending on what's in it.
It's all zeros in it.
Yes, all zeros. So ID is zero, name is empty string, abbreviation is the empty string, census region name is the empty string. The zero value for a struct is not nil. Okay? So the structs cannot be nil. So if we want to have them be nil, we have to use a pointer. Because pointers can be nil. Okay. That's the idea. And so if we want to return an error, we usually return a pointer. Okay. So let's go look up CSV. So we go to godoc.org and we search for CSV. And look at that, encoding slash CSV, package CSV reads and writes comma separated values. Well, that sounds like what we want. Package CSV reads write. A CSV file contains 0 more records, 1 or more fields per record, each separated by a new line. So the fields are separated by commas, and the rows are separated by new lines. They go on and on about the format. We don't care, we already have the CSV file, we're just reading it. So this looks familiar, doesn't it? Okay, so we go to a reader. A reader reads records from a CSV encoded file. That sounds like exactly what we want. Okay, and look here, you can make a new reader. And it has a read method that returns a record. Okay, so a record is a slice of strings. Does that make sense? So what is going to be in that slice of strings? Whoops.
It's gonna be ID, state, abbreviation.
Exactly, it's going to be 1, Alabama, Al, USA, and so on until we get to 11.
Does it recognize them as separate lines?
Yeah, so it's going to return, one record is 1 row.
Okay.
And the first record, what's the first record?
Oh, you mean
The headers. Exactly. The first row are the headers because look, there it is. Row 1 is headers. And then the second through the 50th row, 51st row are all the states, right? Each one of these is a separate record. So when we call read, it will read 1 record. Now if we call read all, look at that. What's that type?
It's a slice of slices.
It's a slice of slices. It's a slice of slices of strings. So this gives us mini records. It gives us all the records, okay? And then we could loop on that. Our file is really small, so maybe we'll just use this, or we could use this and do them one at a time. The advantage of this is, once again, we use less method. We don't have to, we can walk through the file, do 1 row, and then the next row, and then the next row. If you had a CSV file with millions of records, that might actually matter, right? Remember the problem of, well, what if it's a 100 gig CSV file? You might think that sounds nuts, but that's actually pretty, not that unusual. Often CSV files are very large. So we'll use read to do it. Okay, so that's how we can read a CSV file. Now it takes a reader, which we know can be a file, right? We've seen that before. So the process is we're going to open a file. So f air os.open. I'm just going to hard code it. .csv, okay? And the error is not nil. We're just going to log that. And then remember defer f.close. Now we need to parse the CSV file. Okay, so now we have to create a new CSV reader. And I say CSV.newReader. And I pass in, what do I give it?
Give it F.
F, the file. Because I'm reading a CSV file.
So I would think, just from what I've seen before, that since F is a pointer to a file, is that what NewReader takes? Oh yeah, because NewReader then creates the reader, and that influences the reader interface. Never mind. Is that right?
NewReader takes a reader.
Oh, okay. So I thought F, when you open a file, gives you a pointer to a file.
It does. This is a star file.
Yeah.
So the star file implements the reader interface so we can use it.
Oh, right. Okay, got it.
Now actually CSV reader does not implement the reader interface.
I got it. Thank you.
It's not an IO reader, it's a CSV reader.
Got it.
Okay, so the way we use CSV reader, if we go back to the docs, so we made the new reader, we have this guy, we call read. It returns record to string, or error. So read reads 1 record from R, the record slash string is scope. So basically the idea is we're going to, in a loop, we're going to call this over and over again until error is not nil. So, an example here. It may not. They've been adding examples, but sometimes they don't have very many. And I guess this is a case where they don't. That's kind of too bad. Okay. Well, I'll show you what you could do. Often when I have a package that is sort of missing examples, you can click this, and you can see 720 examples of people using CSV, okay? And this might be a good place to find out how to do code, right? But here's something. It doesn't exist anymore. What else we got?
I love the descriptions on some of those. As I chain Oracle with Go.
This is
That one?
this is not like part of the Go library. These are things people made.
How did you get there?
I clicked at the bottom.
700.
Is imported by 720
Oh, wow,
packages.
awesome.
So we gotta find something in here that's good. Rather than- Yeah, let's look at this guy. So you click up here, you click this guy, and he takes you to the source code. And then you go look in here. We could do a search. New reader. That's probably not it. We want CSV.new reader. I'm missing something. Maybe he stopped using it. Anyway, you could spend a long time doing this. But that is generally the process you take, okay? If you don't understand something, go look for examples until you do. There's got to be some CSV in here. Here we go. That looks like something. Aha! I found something. So this looks like some sort of game engine or something. And they have taken buff here. So if we go look at that. Here we go. Yeah, it's like it's XML tiles or something. Buff here is a buffer. So they've given it some data. Anyway, they're just calling read all. So we could do that. But I think we'll want to do a row at a time. So this is what I'm going to do. Row, or we'll call it record just to be consistent. Error, CSV reader dot read. If error is not nil, we're just going to break, okay? So this is an infinite loop, and this is why Go has that shorthand syntax. It turns out infinite loops are super common. It seems crazy, but it's because you do this a lot. Do something if there's an error, break, okay? I'm going to do it like this. If error equal io.end of file, then we'll break. Else if, we'll display the error. Because error end of file is normal. Okay, so now we have a record. At this point, maybe it's worth printing that out to make sure we're doing what we think we're doing. Okay, so we've opened a file. So I'm getting an error. Why am I getting an error? It says missing return at end of function. Because I have a return type here, but I'm not returning anything. So you guys remember what I said we could do to make this go away?
We can underscore it.
Panic. Panic.
They always tell you panic, you guys don't help anything.
Just panic, man. Okay. We're not using
Kind of
meters.
funny.
Okay. Go install. And then we're going to call state information, which is the name of the program. Look at that. I think we're making progress here. These are CSV records, right? See, ID, name, abbreviation. ID, name, abbreviation.
That's the first line.
You're right, that is.
That's the first row.
Yep. Go. So it looks like it read it all properly. That all looks good. So now we have a slice of strings, right? What's the type of record? Does anybody know what the type of record was?
String read. Or string slice.
String.
Yeah, this is a. Right? How do I know that?
Reading the doc.
Reading the docs. Okay? They say that's what it does. It says.
That's not a trivial question.
slice of string. That's the first thing it returns. The second thing it returns is an error. Okay. Okay, so now we have our record and we need to convert it into a state. How do we do that?
Well, your record is a slice, so you can range over it and then check for the field and, you know, when that's the value, and if it's the value that you're at, then you can stick that into your struct and return your struct.
Okay.
Or is that too complicated?
No, no, no. That sounds right. So what is the parse state going to take in?
Our state will take in
A record, right? And what's the type of record?
slices strings.
Thank you. That's what we're going to take in, and that's what we're going to write out. Here's an issue here. Like you were saying, we could skip the first row and just hand it all the others and hard code that we know that the first record, the first column is the ID and the second column is whatever. Well, wouldn't it be nice if it was more dynamic? Like, what if we rearranged the columns? Saved it. Wouldn't it be nice if our program still worked? So we'll implement that, okay? So to do that, we need one more thing. The first thing we need to do is build a map, okay? So these are going to be our columns, a map of a string to string, or actually to an int. And we're going to loop over. So I need a counter here. I'll call it row count. And at the end of my loop here, I'm going to, so I'll do it this way. Okay. So here's an infinite loop where I have a counter. So if row count is 0, then I'm going to fill in my columns. Okay. And the way I'm going to do that is I'm going to loop over each column. I'm going to call this index IDX. Range record, and that's going to give me each column. I'm going to say columns at column equal index. Okay. So let's print that. And I'm just going to do the loop once and break, okay? So I'm just going to break. So now we should expect to see a mapping of the column to the position in the record where it is, okay? There. So ID is in position 0, and country is position 3, and so on and so forth. So we can use this to figure out how to get the column we're interested in, okay? So I'm going to pull this out up here, because we need it for the else case. And then I'm going to pull this out right here. Okay? So now I'm going to pass it in. I'm going to get state error phone equals parse state. Pass in the columns. And I pass in my record. And that's going to parse the state based on this mapping of columns, okay? So we need to handle our error. It's not nil, and log it and die. Okay. So now we don't need to break anymore. Okay. Now I got to do something with state. I'm just going to print it. Okay. What is this program going to do right now? Current state. It's going to panic, right? Because I haven't implemented this yet. So let's make sure that does what we think it does. Not implemented. Okay. So the first thing we do is get all the columns, and then the second thing we do is parse states. And we do that for every subsequent row, okay? Because row count 0 here, it's incrementing, and then we parse each state. So in here, we need to parse each state. And the way we're going to do that is all we care about is ID, name, abbreviation, and census region. So we need to get the ID. How do we get the ID? It's the record at the columns at ID. So maybe I'll break this out so you can see it a little better. So first I get the position for the column. So the position for ID is 0, and then I get that from there. Okay. This isn't going to work though. Maybe I'll show you the return. So the return is like this. So I'm creating a new state, and I'm setting ID to ID. Okay. The reason that doesn't work is that you cannot use type ID type string as type int in field value. Okay. So ID here is a string, and it expects an int, right? So we have to convert this into an int. Remember how to do that? Exactly. So str convert, and we'll use a to I to do that. Now we check our error, and maybe you can see why I wanted the star state. I can say return nil error. Okay? So now we got the ID and we converted it. Now if the first column, if the value in that first cell is not a number, this has an error, and then our program dies and will print that. It'll say, invalid format, which is maybe what we want to have. So that's good. So now we have the ID, we just have to do all the others. Is everybody following this example?
The one place where I just have a little bit of ambiguity or confusion or whatever is when you're pulling out the columns, you can scroll down to that and making your map. It looks like you're doing that off of the first row.
Yeah, that's
So
right.
when I kind of was thinking about your spreadsheet getting jumbled, I was like, maybe somebody went in and did a sort on it. And so, your header row ended up like at line 33 or something. That's where it fell alphabetically for however they sorted it. And then your columns would then be coming off of your first row, which would be some random state, right?
Yeah.
So you're always assuming your header is in row column position 0.
Yep.
Or row position 0.
It'd be impossible to tell the difference between a valid row.
Yeah, I see.
A header row.
Check for, so.
But that's very typical to have a CSV file with a header row.
Yeah.
Okay, so we have ID, we have to do the rest, so I'll do the rest real quick. They're a little easier. So I'm going to copy that, paste it, and then replace that with abbreviation. I'm going to do the same thing. Census, region, name. I'll rename that guy to match our casing.
You renamed it to match what?
Our case convention.
Oh, okay.
And then, so now we've mapped all the other columns. They're easier because they're already strings, so we don't have to do any conversion. Theoretically, we should end up with the states. So let's see.
Drum roll, please.
Look at that. We have states. 31, New Mexico, and M is abbreviation, regions west. Okay?
Why do we have an ampersand in front of that there? Because,
They're all pointers.
okay. Oh, because all you did was print out I don't even know what to call it, object, or what is it?
State.
The struct.
Oh, yeah.
It's a
Well, it's state.
For this drug.
state.
So now we have states, okay? Now what was the original problem? We've forgotten the problem. Return statement takes in the state code.
I guess on the return there, why didn't it show the address? Because before when we had the pound, or the ampersand, it showed the printed something with an ampersand.
Only when we're using the print after the %p.
Oh, got it. Where is that the code? All I saw was print.
So yeah, if you're just printing it, it's the object, it's what's in the object, the ampersand.
Wasn't that what we did right there, 6.3 print line?
Yeah. It
Yeah.
prints the state. The default print thing for a
If it's an
struct.
object, just that they print the object with the ampersand, but it's the pointer. Yeah, use
Okay.
%p and print that if you specifically want to print the fx value. If it's not.
Okay. All right, go on.
So we're supposed to give it a code, and it's supposed to give us information. So what does that sound like? What kind of thing do we need to use to do that?
We need
Either an arc or a input.
So this is a lookup table, a map. We use map to do lookup, right? And what kind of map are we going to have? We're going to have a code to state map, right? Okay, so I want to have like Alabama, AL is mapped to, and then we have, you know, the name is Alabama, right? And then the abbreviation, etc., all that stuff. We want to have all that stuff, okay? That make sense? And then what we're going to do is we're going to go look for that, for the code the user enters. If we find it, we're going to display a table. If we don't find it, we'll have an error, okay? Yeah. So we need to make a map. So we'll do that. State lookup table. We'll just do state lookup. Map of string to state. Okay. We could use pointers here or not. Up to us. I'll get rid of them. Why not? I'll show you how to do that. And then we're going to add to it. So now we have our state. And the way we do that, we take the state abbreviation equals the state, except we have to do that, right? Because that's how we convert a star state into a state. But like I said, if we used the other type, we could get rid of that. Okay. Because now this thing is storing pointers, and we have a pointer, so we're good to go. Either way. So now we've built up our big state lookup, and we just have to get from the user the thing they entered. So let's make it, I do state-information AL. I pass it on the command line, okay, because that's the easiest. So we'll say if the length of os.args is less than 2, we'll have an error. Expected state code for abbreviation. And so we'll say colon equals os.args at 1. And there's our abbreviation. And how do we get the state out of that? So we have state lookup, and we put the abbreviation in there. And that gives us state okay. The okay here will be true or false. If it's false, then there wasn't anything in there. You entered XX, that's not a state, and so it would be false. Okay, so we need to check that. If not okay, log fatal line invalid state abbreviation. Okay, and now we have our state, and we just need to print a table. So let's just make sure that worked like we thought it would, and we'll just print the state as it is.
So when you have state lookup's a map, right?
Yes, it is.
So when you look something up by map, you can say have it return the value and the OK thing, and the
That's
OK is an error.
It's a Boolean.
Oh, it's just Boolean, okay.
It's true or false. If it's true, then it was in there and the state will be set. If it's false, it's not in there and the state will be set. So if this works, we should be able to go install. That looks like it worked to me. Let's try a different state. There we go. Okay? Now we just have to make a table. That's really easy. Right? We do this thing again. We'll do body. Table. Row. Header. I don't know. Abbreviation. And then we'll have name. And we would do Lord. We'll just do these two. And then we'd add the rows. Okay? So we printed that out. And then this is where you see this break-in, break-out pattern, very common with HTML. Eventually we want to close with the closing table and the closing body. Closing HTML and so on. And then in the middle, we'll loop over, well, we can just put it directly in there. Right, it's complaining about I didn't use it. Okay. So, if you had more than one row, but we only have one row, so we can say, TD plus state dot abbreviation, and then TD state dot name. And that should print out our table of state information, theoretically. Oops. There, now we have HTML. Oh, we're missing a closing TR. So fix that. And run it again. And there we go. So if we write that to a file and then open that file, we get our state information. If I change it to be California, I get California. Okay? So go through the code again. Open a file. I'm going to create this state lookup. I'm going to walk through a CSV file. So I make a new reader of CSV records. And I'm going to store the columns in this map. I walk through each row, each record. If there's an error, I log it and stuff. If the row count's 0, that means I'm on the header row. So then I store all the columns. But if it's not 0, then I parse the state. And then I store it in the state lookup. And then finally, I go get the thing the user passed, I look it up in the state lookup, and I print it out. Okay? Questions?
It's pretty awesome. You know, you're just like right from the very base, building a dynamic page, so to speak. We're starting to get the workings of it.
So, things we could improve. I'm going to add another type. And we'll call it state information. Okay? The reason I'm going to do this is I'm going to give it a field columns, which is a math of string to int. And then I'm going to change parse state to be a method. I'll call it SI. Well, actually, I'll call it info. And now I don't have to pass that in. And instead of columns here, we'll say info.columns. And then I'm going to create another method. Called setColumns. That's going to, you give it the record, and it will set the columns. So it's expecting the header record. I'll just do it this way because we don't have to have an error for that. And so we don't need this guy anymore. And we'll take this out of there, put it in here. So this becomes info.columns. Did I spell something? I did. Information. And now now I do, I have to create the state information. So I'll do that, state. And then I'll say info dot set columns, give it the record. And then this becomes info dot parse state. And so on. Okay. So now we're sort of pulling things out into another struct, right? And so now the columns are tied to the state information thing. We could put the lookup in here too, okay? And we could do that, and then we could keep going down that route. And slowly this code in the main function would start to shrink. And that's sort of the point. But this should be enough to get some of the other examples done. Okay.
Yeah, put that at scratch.
So the next example is very similar. Download the CSV file. It contains information about monuments in Champaign, Illinois. And you're supposed to write a program which finds the monument at the highest elevation and display information about that monument as HTML. This is like identical to the program I just wrote. And find the monument at highest elevation sounds an awful lot like find longest word. So this should be doable program. Okay? Make sense? Questions?